G'day, Matt here. We're going to have a go at this exercise here, which is asking us to do a trace of an insertion sort implementation. So insertion sort's down here. Actually, that's slightly out of date. The one I've got up here is the one you'll see when you get to see the worksheet. But the question's asking us to trace the algorithm, and providing you an algorithm trace is not something that I can effectively do just with a picture or with some words. You really have to see someone doing the trace. And there's a black art to tracing. It's something where you want to find your own technique that works for you. But for a lot of people, they'll need to copy someone else's technique to get started. And that's what I'm going to show here. So my technique for tracing this particular one. You've also got to be a bit flexible in how you trace things, not always trace them in the exact same way. Adjust your tracing techniques to match up with the actual problem you're dealing with. So I tried a few things on this one and settled on this particular style of tracing. And in this style of tracing, what I do is I put down every variable that exists in the program, and I just keep track of the value in that variable. Every time the value changes, I cross out the old value and put the new one in. And when my variables are quite small, I can do that horizontally, you'll see. And when my variables are big, I have to do that vertically. So that's what you'll see me doing here. Now, the variables in this program, it's not a full program, it's a function, but we're assuming there's a function call. And we've been given two parameters here. Well, there's only one parameter needed now, it's the array. So I start off with that variable, the array. And because of the question told me that it's going to be instantiated with 2, 1, 5, 0, 6, that's what I write down. So I've got that variable and its current state in the program. The next line here, which is line 4, I put the program over here so I can highlight which bit I'm executing at each time. This bit here creates another variable and sets it to 0. And then this bit creates another variable and sets it to 0. And that last bit creates another variable and sets it to 0. Okay, so those three variables are there, and that's all the variables that I'm going to use in my program. Don't think any more come into existence. I already know that as I do this, I'm going to find I need more space to expand out my arrays. So I'm going to take them from the top and just put them down the bottom where there's a bit more space. Even though that was the first variable I saw, I'll store it down there. These other ones are just integers, so I don't need so much space. I can use this horizontal space over here to expand them, and I'll use the vertical space down here to do the new versions of the arrays. The question's also suggested that we should note the place in our trace whenever we hit the end of the outer loop. And that's because they've described the invariant for the outer loop. So the start of the outer loop and the end of the outer loop become important locations because those are the locations where that invariant has to be true. And you'll see me do that. All right, let's get going on the program. So first thing that happens is we enter the loop. So j goes to 1. So old version of j gone, new version of j exists. I then have to check that j is less than array length. So array length is 5 in this case. I might just pop that over here as a little reminder. Array length is 5. 1 is less than 5, no problems, so I enter the loop. Key gets set to array j, which is array 1. So key gets set to 1. Array 1 being that number there, number 1. Then I get set to j minus 1. Well, j minus 1 is actually 0, so I crossed it out because it got reset, but it got reset to the same number. Then I have to check, is I bigger than or equal to 0? Yes, it is. And is array I less than or equal to key? Well, array I is array 0 in this case. Array 0 is 2, and 2 is not less than the key. The key is currently 1. So this loop never enters at all because that condition is already false. So we bounce right down to line 12 and we run this line. And that makes an adjustment to the array. So I'm going to pop in that adjustment here. So that's the old array gone. And the new array is mostly the same, except that I plus 1, which is 0 plus 1, which is 1, has been set to the key, and the key is 1. Oh, so that actually made no change. But it was an assignment, so I'll cross out and pop it in, and I'll just highlight exactly what did get assigned. And this is that location we had to keep track of. So I'm going to keep track of that location and just note that this time j was equal to 1, because we're going to come back to that location over and over with different j's. So that outer loop has completed one iteration. We jump back around to the top. So j gets incremented. J goes to 2. Next up, key gets set to array 2. Array 2 is currently the value 5, right there. So key gets set to 5, and I gets set to j minus 1, so I get set to 1. Is 1 greater than or equal to 0? Yes. Is array 1 less than or equal to 5? Yes. Because array 1 is 1, key is 5, so that's true, so we enter the loop. So now we're making another change to the array. In this case, array I plus 1, which is 2, is being set to array I, which is 1. So array 2 is being set to array 1. There's array 0, stays the same. There's array 1. Array 2 gets set to the value of array 1. And the rest stay the same. So I'm just going to note that that's what happened. Array 2 got put into, array 1 got put into array 2. And now the inner loop finishes. We go back around to the top, so I goes to 0. Is 0 greater than or equal to 0? Yes. Is array 0 less than key? Well, array 0 is 2 and key is 5, so yes. So this little adjustment happens again. This time, because I is slightly different, array 1 is getting set to array 0, and so that's this change. Okay, and so that was this being moved into there. So even with no intuition for what an insertion sort does, we're starting to see we inspected key 1 first and decided to do nothing. Then we inspected key 2 and decided to shift that one over, shift this one over. And the next thing we're about to do is to put 5 back in that slot, because that's how insertion sort works. But let's trace it anyway. So this loop finishes and I goes to minus 1. Minus 1 is not greater than or equal to 0, so this loop finishes, and we are running this line. I is currently minus 1, so array 0 gets set to key. Array 0 was previously 2, but it's now the key. And that was the special line we were keeping track of, plus plus, and this time j was equal to 2. Okay, next up, we go back around the outer loop, so j goes to 3. Key goes to array 3, which is 0. Then I goes to j minus 1, which is 2. Is 2 greater than or equal to 0? Yep, it sure is. Is array 2 less than key? Well, array 2 is 1 and key is 0, so no. So that fails and the array never executes. So the loop never executes. We jump straight down to here. So this line tells us that, done it again. Array, we've got to keep track of our i's. Our I is currently 2. So array 3 gets set to key. Cool. 0, 1, 2, 3, 6. And what's the key? Well, the key is 0. Okay, so it didn't actually make a change. So yeah, but it was the spot where we did the thing, and it is that spot in the code. Okay. So this was the situation in insertion sort where that number was already in its right location. back around to the top, and we go to j equals 4. 4 is still less than array length, so we keep going. We go to key equals array 4, so key goes to 6. I goes to 3. Is 3 greater than 0? Yes. Is array 3 less than key? Yes. Because array 3 is 0. So we do this line, which is array 4 equals array 3. Zero. So that's the new one. Array 4 got given the value from array 3. By the way, I should have been crossing all of these out along the way, but I like to leave, I want to make them more visible above, so you know that it's just the bottom one that's the important one, that's the current one. Again, adjusting my tracing style to the question at hand. So I now goes to 2. I will learn when I've got the right pen. I goes to 2. And we loop again. Is 2 greater than 0? Yes. Is array 2 less than key? Yes. So 2 is less than 6. So yes, this does have to happen again. So we execute line 10 again. And in that case, it's setting array 4 to the value in array 3, which was this little movement here. And as good programmers will keep tracing by hand, but we can probably see what's going to happen for the next little while, knowing that 6 is our key constantly. Keep that in mind because it's going to scroll off the bottom of my screen. 6 is our key. We go back round and I is now set to 1. I is now set to 1. Is 1 greater than 0? Yes. Is array 1 less than key? Yes, because array 1 is 2. So array 3 gets the value of array 2. That is 5, 2, sorry. Array 2 gets the value of array 1, because I is currently 1. So that's 2, 1, 0. And that was this little movement here. And back round, I goes to 0. Is 0 greater than or equal to 0? Yes. Is array 0 less than key? Yes. 5 is less than 6. So we're in the loop doing this again. In this case, array 1 gets the value from array 0. And the movement we did was this little movement. And we loop around again, and I goes to -1. -1 is not greater than 0, greater than or equal to 0, so we jump back down to this line, which sets array 0 equal to the key, which is 6, 5, 2, 1, 0. And that was our special spot, plus j equals 4. And now we jump back around and j goes up to 5. Whoops, the one time I didn't do it. J goes up to 5. 5 is not length less than the array length. So that outer loop finishes and we return. So all this code is now finished executing and we've got our full trace. So you'll find in the solutions a copy of this trace for use in the later answers. But that's how we came to the trace. And you can see inside the trace I forgot to put the dot under the 6 being set. You can see inside the trace the way the program has operated. I forgot to also put the 5 being set, which was there. We first picked out the first element 1, shifted what we needed to, and we first picked out the first element 1, shifted what we needed to and put it in place. Then we picked out the next element 5, shifted what we needed to and put it in place. Then we picked out the next element 0, shifted what we needed to, which was nothing, put it in place. Then we picked out the next element 6, shifted what was needed, which was everything, and put it in place. There's our insertion sort in action.